So under week 10 in Blackboard, I've got a couple sample data for you to practice with, and I'm just asking you to just do one of the samples and write the single sentence for the data analysis regarding the p-values and the analysis there. And I haven't given you the details as to what the study was and what the data is really implying. I'm going to show you an example where it's not the same group. It's not within the same group. It's actually two different groups. Group 1 is a set of people, and Group 2 is a different set of people, and then it was analyzed. So if we click on sample data as the file and we open it up, let's see here. Let's open up. Let me close this down because I already did a little bit of it to show. All right, so this is what you would see. All right, so right here, I'm going to tell you that there's two different groups. If this was the same group and we call this scenario 1 and scenario 2, then you would do the Wilcoxon test. I'm going to talk about when there's two different tests, two different groups using a Likert type scale, we're going to do something called the Mann-Whitney U test. All right, it's the same concepts. It's a non-parametric test, same statistical analysis, but instead of using the same group, a one-pair group, you're going to actually use two different groups, two independent groups. So group 1 is a set of pilots from, let's say, private pilot class, right? The private pilot class. Group 2 would be students from the commercial class, right? And we're measuring something. I don't know what. This is just an example data to practice manipulating this and kind of working with Excel, as well as SPSS and understanding how to write up the analysis. So the first thing we want to do is, this is an individual. This row is one person. And there's X amount of people down this row, right? Same thing, group 2, this is one person. And we want to find the average of their score for this item, for the scale, right? And if you remember, it's equal to average, and then select. And then what I'm going to do is just put a letter there at the bottom so I can quickly hit copy and paste without having to scroll down. Same thing, the average equals average. Oop, that's a little too much there. Just put a letter. Copy, paste, boom, there you go. Select that column, we'll make that red. And we want to make it 2 decimal places again. Same thing with this guy, we want to make it 2 decimal places and red, just so it stands out a little bit more personally. Alright, so I've got two groups, two average scores, but they're two different groups, they're not the same person. So we have to do something slightly in Excel. Sorry, not Excel, in SPSS. So I'm back in SPSS. I'm going to create a new data set or data table. And I'm going to go to data view and I'm going to copy over group 1. So I'm going to copy it over in the second column. I'll explain shortly in a second here. I'm going to copy the results from group 1 into the second column. And in the first column, I'm going to label this as group 1. I copy and paste down all the way till the bottom. That's all of group 1's data set. Well, because what I'm saying is the column 1 is going to be called the group value or group, and column 2 is going to say the score, whatever the score is for that. Sorry. The score is for that scale. I don't know what that scale is for the time being. It's not quite important. It's just the concept here. And we know that it's an ordinal scale because it's a Likert type scale. And then group is nominal. It's named 1 versus 2. Group 1, we can call it private or pilot, whatever you want to call it. It doesn't really matter. In this case, we're coding it as number 1, and then we're going to code group 2 as number 2. So back to data view, and then back to my Excel sheet. I'm going to copy over group 2's set of information and paste it over here, and I'm going to call that group 2, copy the number 2 all the way down for all of group 2. So now I have, kind of similar to Excel, you can do this in Excel and just make it all and then copy it over from Excel into these two columns. But basically I've got a column of labeling the group and associating it with the score in the second column. As I scroll down, all of this is group 2's scores. Why do I do this? Because now that the analysis is a little bit different, right? Because I'm comparing two groups' scores between the two. So I go to Analyze, and then I go to where I was before, non-parametric tests, and we go to Legacy Dialogues, and we go to two independent samples. That's what we're doing. We're doing two different groups, two independent groups, two independent people, sets of people, two samples. Click that. And my test variable list, or the test variable, is my score, and the grouping variables, I called it group, right? So that's the group. I now have to define the group. Group 1, I called it group 1. If I named a letter, a word, if I called it pilot, or a different number, I'd have to put that in there. I like using numbers because it makes it a lot easier, or a single letter. Most of the time, numbers are the best way to do it. Group 1 is group 1, group 2 is group 2. Pretty easy to do it. Hit continue. I know I want a Mann-Whitney test. Look at all the different statistical analysis. There's a bunch of math gurus that came out and has all these different test types. We're going to use Mann-Whitney U. It's a commonly used statistical test between two groups in this particular example. We hit OK, and we've got some numbers here. And this test statistics is pretty important. I'm going to go over that. And our mean rank, so what that says is group 1's average score was 60, and group 2's average score was 74. That's ranking. So what we might want to do is actually find some basic analysis. So if I go back to average scores, let me go back to here. And what I want to do is I want to know what is my average of the averages. All right, so I can say, okay, generally, what's going on? What's the difference between this guy and, oops. Alright, so we can see that group 1 has a lower score than group 2. Okay, so we've got a comparison here. Group 1 has a lower score than group 2. If you look at this, that makes sense. Group 1 has a lower mean rank than group 2. It doesn't give us the actual number, but just the mean rank. So let's look at that. That just gives us an idea of how to explain something. This is really more the important thing. Like I said, Laird statistics is pretty great. So if you go to Google and just type in Laird Mann-Whitney U, and you choose the first one that comes up, SPSS statistics, Laird statistics kind of tells you how to do it. It explains the whole purpose and how it's all set up and what the assumptions are and how to set it up in Excel, SPSS, and how to label things. If you go to the next page, it tells you how to analyze and look at the data. So if we look at the test statistics here, it's a U statistics, and this is the sentence I care about. Is this significant or not? Well, in this case, this value for a two-tailed is 0.014. That's below 0.05. So we can say that if my a priori alpha value was 0.05, this is statistically significant. So we can say the sentence is, from the data, it can be concluded that this group, in this case cholesterol concentrated in the diet group, was statistically significantly higher than the exercise group. And then we put in brackets the score. U, here's the Mann-Whitney U score, equals 110. P equals 0.014, and that's it. So we say that there is a statistical difference. So let's look at it from our point of view and relate it to this sentence. So from our data, it can be concluded that group 1's, let's say it was willingness to fly scale or willingness to fly score, group 1's score was statistically significantly lower, right, because we saw that this number was lower, than the scores from group 2. And then it would be brackets U equals 1,747, comma, P equals 0.039. In this case, this is less than 0.05, so it is statistically significant. So that's how you do it, between groups versus within group. Within one group would be a Wilcoxon test. Between two groups, that's using a Likert scale, would be a Mann-Whitney U test. If you're using an interval scale, so you're using a performance scale, 0 to 100, a graded scale, A, B, C, D, E, F, based off, no E obviously, based off a score on a test, you would use a t-test. And it's a very similar thing in SPSS. If you go to Analyze and go to, you set it up similar to this, the same scores, but instead of this being a Likert scale, the score would be an actual, instead of score, it would be, if you go to variable view, we would change this to not a scale, an actual scale. And we'd analyze this and compare the means, and it'd be an independent samples t-test if it was between two groups, and it'd be score and grouping variable. We still define 1 and 2, and we'd hit OK. And right here you would get a t-test. If this was a score, not a Likert scale, if the scores were actual numbers, you would have a value here, significance, Levene's, or t-test. Actually, that's what we want. And we're looking at this number, 0.038. So it's also significant using a t-test rather than a Mann-Whitney U. So this is a slightly different test, but most of you seem to be doing a Likert scale, not a performance scale. So that's how we do it. If any of you are doing a performance scale from, a measured scale in that case, we would actually do a t-test, and we can go over that in a little bit more detail. Or you can do the same thing like I told you to do. You could go to Laird, t-test, take a look at that. Independent t-test using SPSS statistics. It will go over how to do it, what the assumptions are, an example, the procedures, and then you'll also see how to write up the analysis. If you go out, this is the output. This is what we're looking at, independent t-test. This is what we want the t-test for equality means, and like I said, we want the sig two-tailed 0.002 in this particular example is less than 0.05. How do we report it? Here's how you report it as an example. Again, if we were doing a little bit more of a advanced course, I'd go into this in a little bit more detail, explaining the assumptions, making sure your data meets these assumptions before you do the test. For the purpose of this class, we're able to do the Mann-Whitney U, Wilcoxon, or an independent t-test, depending on what your study is. So I'd like you to practice either with any of those samples, but I want you to submit either sample 2 or sample 3 on your own.